Hey everyone, this is Will from FM Reduction Squared, and we're back to do a little bit more recording for our 10th Developers Vlog for Space Crusade. If I sound a little bit out of it or retarded, it's because I've been working all night on this thing. And the 5 liters or so of soda I've guzzled down over course of about 8 hours is starting to wear off. So what I've been focusing on the past week is just trying to get these damn casino games going, and currently we're working on the poker stuff. You saw me working on it a bit the other day. I'm not sure how far I got on it. I'm not going to go back and look see where I got to, but added a bunch of stuff, and lots of stuff actually, as you can see. And so what happened is I decided to go through and say, okay, so we're just going to part out each section of the minigame, right off the bat, instead of having to go through and then take everything out of a huge, ginormous block of code and making sure we got sections and whatnot. So that's what I did. That's what all this stuff is from, as you remember me saying before. I did add in something new though, which is this pregame setup. And what that does is, that's declaration, what definition. What that does is it just essentially sets up the ante, clears the hands per round. Because the ante will change and the hands need to be cleared. So that's just something I've added. A lot of the work's pretty much been focusing on the AI right now. We got the player stuff done. It wasn't too hard to do that. So you got the pregame set up the deck, click the ante, then determine the dealer. In poker, and at least in this version of poker that I'm making, and in non-casino dealer versions of poker, there's the dealer rotates around the table, and essentially what you have is in actual poker, it's like you have a button that'll say dealer on it, and that'll indicate who's the dealer. But since we don't have that yet, because we're doing this all text-based, that button becomes essentially just a flag in the hand class, and so we just rotate around that flag per round that's played. That always starts on the player and goes from the player through the AI player's vector, then back to the player. Now for the bets, phase 7 here, this is for the player bets. Essentially what happens is you just go through, you check to see, you essentially have a betting order, which is set up also when we do the dealer thing, I believe. Essentially it just puts the dealer first, and then whoever comes after the dealer, then up to whoever's just before. So in other words, if the dealer is, say, the third AI player, then the turn order starts with the 4th AI player. You go to the end of the player's vector, add the player in, and then start at the beginning of the player's vector until you get to the dealer, and then after that you stop adding them because you'll have added everyone in after that. The dealer always goes last in poker when you have it set up like that. And then we do the betting order. So what I have set up here is that we're using a couple flags. For the betting order, we're using B raise and B check. Now check means that that there has not been a raise, or that the person who made the raise, it's come back to them and nobody else has raised. They've all called or folded, and so they check. And in our version of the game, when you check, you also have to re-bet. So in other words, if the player that's raised, if it comes back to him, nobody else is raised, everybody else is called or folded, if there's still people in besides that player, they have to bet whatever they raised. So let's say that that player raised 500, so they have to put 500 more into the pot on the check. That's not all. That's not really how it's done with poker. But again, creative license because this is in the future, so there's going to be different rules and little quirks like that make it either harder or more. And here we are with one of my infamous lost word sections or segments, trying to figure out what word I was going to say. It builds up more tension, let's put it that way. So I have no clue what the hell word I was going to use. The player section was not too hard, because all you have to do is just say, okay, player, what do you want to do with all this stuff? Here are your cards. Here's what was bet if there was a bet from before, and what chips you have. What do you want to do? And then just do that stuff. Now the AI, though, on the other hand, oh my god, I was talking to some guys over on the League of YouTube Gamers chat box about this, and it kind of drove me insane for a little while trying to figure out how the hell to do this, because it's just crazy how this works. So if the player is not the current bettor, it's actually bettor, not better. I've been using that wrong like an idiot. I started fixing it in places, but if the player's not the current bettor, then we have to go with the AI, because one of the AI is going to be the current bettor. So we go through this for loop with I2, looking for the current bettor in the player's vector. And we're also using, for the state, we're using fold and all in to tell the game not to process a turn for whoever, if they have one of these two in it, not to process a turn for them, because if they folded, then they're not playing anymore. And if they're all in, they have no chips, so there's no reason for them to do anything. But yeah, we go to scdv10 AI B Calc. So all that stands for is Station, Casino, Poker, 5-card draw, AI, bet, calculation, essentially. But it's not just calculation, it's the whole thing. So we go to definition, and this is a huge thing, and you can tell by all this stuff here that it's going to be something serious. So 8,480, 8480, 906, jeez. Yeah, it's huge. All in its own. So here's what happens. I was trying to figure out how the hell to do this, because this part wasn't too hard. What I'm doing is that if there was no last bet, in other words, if this bettor is the first bettor of the round, then they get to use all this cool stuff here, which gets paid off later on. And I actually spent about 4.5 hours total a day doing just all these random, just kind of writing down things, random values that fall in line with whatever these ranges are, and getting 5 random cards and just putting it all through this whole thing to make sure it was sound. And unless I have grossly screwed up, it looks like it's going to work pretty well. But yeah, so if this is the first time anybody's betting, then we use all this stuff. So we set up a range, and this is just a base range. The base bet will be chosen out of this base range after the range has been multiplied by the AI bet range multiplier. And then the AI base bet is chosen from the range after the multiplier is added, and the multiplier is 1 to 20. Actually, it should be 1 to 40. I did change it, didn't I? It should be 1 to 40. And the var should be... What do I have the... bvar 1 to 40... 0 to... Okay, we'll leave it as 40 because I'd had that at 20 before, then I changed it to 40 because I wanted to have there be larger bets, essentially, because they were all the bets I was getting before when I was first doing just taking random values from the things after this stuff, and putting it in. I was only getting bets of up to like a max maybe 500 or 600. I wanted to have some much larger bets for other stuff, and that's why I changed those. And so we're getting up to bets of max. I think the largest bet I've had so far, calculated out so far, has been, where's the page at? Is this it? Yeah, it's been 9,155 with a 39 multiplier and base range of 47 on the low end to 138 on the high end, which calculates out to being a actual base range of 1,363 low to 4,002 high, and then that's put through all the other. Then out of that range, you choose the actual base bet, the base bet, which was in this case 39.21, and then that goes through a bunch of other some other functions, but formulas, and that came out to 91.55. But we'll get to that later. I mean, that's what all that does. Now, if there is a last bet, then the base AI base bet is just the last bet. You essentially skip everything, all this stuff. You don't multiply it out. You just find the range. And if I look at this now, this isn't even in the right place, because that's chosen before the multipliers are added. Derp. And all my ice is gone. Damn. Although Dr. Pepper, or rather Diet Dr. Pepper's, I can drink it while it's warm. It's just rather have some ice. But anyway, so that's all that. This is the base bet variation value, and this is used to multiply the base ranges after they've been chosen. So what happens is that you have this multiplier, which multiplies the ranges here, and then you have this variation here, bet variation here, which is used to then multiply. Well, I don't know. Let me see. Maybe we don't use that anymore. Let's see. Or maybe I'm calculating it correctly, which is also possible. So, ADRM. Which I haven't. Oh, that's the multi. Okay. Okay, no, yeah, the variation is actually. It is okay. It's used in that formula I mentioned later on, as a multiplier. But we'll get to that later on. So what happens is now is we go through and we say, okay, we have to examine the player's cards and figure out, what cards they actually have. And the way I do this is I do it by suit and value. Now with suits, you only count them once. Each suit once. So if you go through and you have 4 cards of a certain suit that are all the same, then those cards are put on here. You go through and they're added to this value here, variable rather, for each card you have of that suit. So in other words, we go through I4 is 0. That means we're doing hearts. So we go through the cards vector and the hands vector and the players vector. And we get the substring third character one. I actually changed the, as you see down here, I changed the a parenthesis, value parentheses suit to just value space suit, because it makes it much easier to deal with than having to try and take the suit out from between the two parentheses. It looks cleaner too that way. So we just take that out with 3-1. So the third character and one character from the third character, so the third character essentially. And then we compare it to T card to whatever section it's supposed to be in. So hearts, if T card 1 equals hearts, then we add 1 to the AI same suit 1, which is for hearts, 2 for diamonds, 3 for clubs, and 4 for spades. Then we do the values. The values are done a bit differently. First we go through and we get the values and put them into SC values, which is a cousin to IC values, but this one has strings instead. And then what we do is we go through on another I4 loop and then an I5 loop, and we look for the values there, and then we add into AIR cards, which is an array of 13 elements. Each element corresponds to a specific value. So in other words, element 0 is A, and for every A that we have, we add 1 to that. And so you'll have, A being 2, maybe 4 being 1, and then king being 1, and 9 being 1, and that will be your 5 cards. So after all that happens, now we have to go through and figure out what the hell to do with all that information. And this was part of the thing that was just driving me insane, because I had no clue what to do with it until about later on. This part was kind of, still took me a while, maybe 2.5 hours, 3 hours of trying to figure out what to do. But here's what happens. We'll go over here and talk about the variables that are over here. So it's tie-in over here. So what I wanted to do is I wanted to use flags and variables to kind of deal like a favorability multiplier for certain actions. So in other words, if you had a certain if you get a certain number of points, we'll call them, onto AIC favorability, and when it gets put through the formula or formulas, depending on what's going on with the all-ins, and that value is a specific value after it's gone through a second formula, then the AI will call or check. Essentially, is what that is. These here are for the totals, and I've got some nose bleeding going on. Anyway, so we got the total variables here. They will hold the second calculation values of these, and these hold the points, I guess you can call them, for depending on what your suits and your value combinations are. Then we have the action variability value, which is essentially the same as with the bet. It just adds some more randomness to the equation. You have the base bet, that's all the betting stuff there. AI suit. S-val. I don't think I really ever used that one. And then we got a bunch of flags down here for use when we go into the checking the cards at the very last phase. And then we have the AIR cards for the recurring values. So back over here now, what happens is that we take these favorability variables and set them to a random value to start with, and then that's where they'll start at, and they'll be modified based on what your suits and values bring up. So let's assume for a minute that you get dealt a flush just straight out of the gate. So you get 5 of the same suit. So what's going to happen is that your raise favorability is going to increase by 3, your all-in favorability is going to increase by 2, your call favorability is going to decrease by 1, and your fold favorability is going to decrease by 3. You're also going to add 4 to the bet variability. If you get 4, then we have we change the values up a little bit. And essentially what happens is as you go down, calling and folding go up while raising and all-ins go down, as well as your bet variability going down. Now I'm still working on these values because it is very easy, depending on certain, like if you have really crappy luck and you get a lot of negatives, a lot of bad things, like for example if you have no, if the AI has no combinations whatsoever, it's just all different suits, I guess it would be, well yeah, because either 2 or 1 suit is all treated the same way, as you can see up here. So they have no value combinations, and they have at most 2 suits the same, 2 cards with the same suit. So they get all this stuff piled on top of them. Now luckily for them, the suits only get applied once. Not so with the values. The values you'll go through, and for each one that is true, you'll get hit with that. So for example, I got an example here, so some example hands I had been using. So let's say that we have Ace of Hearts, 2 of Spades, 6 of Hearts, 4 of Hearts, and 6 of Diamonds. So we have 3 hearts right off the bat, and we also have 2 6s, which are the same. So we go up here, 3 of hearts, 3 hearts. So we'd get these bonuses applied. Then we'd have 2 values that are the same, and then 3 that are not. So essentially it'd all be down here. So you get all these bonus values applied 4 times. Now if you didn't have anything that was similar, if you had no similar values, this would actually get applied 5 times. So you can see how that kind of adds up. I actually had to really nerf these a lot to deal with some issues like that were being caused by that fact. That's why these are all pretty much 1s, and nothing really goes over 2s, because adding in 3, like down here I used to have C5 being 3 and this being +2, but when that happened, this would get so high that no matter what would happen, unless you had a situation where you were in a had an all-in happen, which has these treated differently, and I'll show you what I mean by that later, you would almost never be able to fail as far as calling. But that might not be true now with the stuff that I've implemented later on, but let's go down here. So here's the don't we already set that somewhere? AIA var find all references. No, I guess not. I thought we had set it somewhere, but maybe it was something else. Anyway, so this is the variability value. It goes negative 0.2 to 0.7. I just found no reason particular for that. I just found it gives you, that range gives you a nice kind of more even variability on the values. So what happens is we get that, and then we come down to here. So we take all these variability values that we have from up here, or favorability values that we have from up here, and if there are no all-ins, if no all-ins have been done, we use this one. If there has been an all-in, then we use this one, because we want to kind of change up how the AI reacts, and I'll explain that in a bit. But so what happens is here is that we have the favorability values multiplied by 0.1, and then add the AI variability value to that. Then that's multiplied by 2.2, and then that is in turn multiplied by 3.0, and that gets you your total value here. Now, just as an example, we'll go with that. We'll do something here. So, for example, here's all the values I have on this last one here, because that's what I have. I actually went through and did everything, erased it, did everything again, and erased it, and so on for a couple, I think 4 or 5 times. In addition to all the other stuff I did, just for make sure I tested it enough. So my third test hand, or no, fifth test hand, which is what we have all the values here for, was Q5, or rather Queen of Spades, Queen of Diamonds, King of Diamonds, 5 of Diamonds, and Ace of Diamonds. So 4 diamonds, and 2 queens, essentially, is what it would come down to, and then 3 other values which didn't fit into anywhere. For the range, the base range not multiplied was 35 and 96, high and low, or low and high. The multiplier was 11, so it turns out that calculates out to 385 low and 1056 high. The randomized values for the favorabilities going from call, so essentially it's in this order: call, raise, fold, all in. The first one was 4. These are just the base random values. So for call was 4, raise -1, fold 2, and all in 3. And due to all the stuff that goes on, we add 1 plus 3 plus 4 to the call, which comes out to a total value of 12. For raise, it's plus 2 minus 1 plus 4, which comes out to 4. For fold, it's minus 2 plus 2 plus 4, which is 6. And for all in, it's plus 1 minus 2 minus 0, which is 2. Then we also have the bet variation, which was at random a 9. Then we added plus 4 minus 1 minus 4, which comes out to 8. So now we put these values, the total values, through this function here. So we'll start with AI cal. AI call, I mean cal. What the hell, cal? Yeah, it looks like cal to me. Just one. The extra L is silent. It's definitely cal. I'm going to cal the police because I think I'm going insane. No. More like ambulance or something. Anyway, so we got the AIC fave, which is 12. So 12 times 0.1, which comes out to 1.2, obviously. Then plus the AI variability, which is 0.35 in this one. And then we're going to multiply that by 2.2, and then by 0.30. You know, I think I was doing about 0.36 this whole entire time instead of 0. Because I would go 0.3, and then it was just like naturally to 6 instead of 0, so these values might not be correct. No, I guess I was. Never mind. Maybe I was doing it later on. I remember doing 3.6 instead of 3.0, but... So the value, as you can see, is 1.02, so that's essentially 102%. So as you can see, there's an example of how things can go bad, but that gets corrected later on, kind of. Now let's do the raise. So again, 0.1 times 4, which is 0.4, plus 0.35 times 2.2 times 0.30, which is essentially almost half, 50%. And these values are not going to add up to 100%, obviously. So the next one should be, will be multiplied out 0.62. So again, 0.4, or no, 6, 0.6. Plus 35 times 2.2 times 3062. Yep. Reconfirming all my previous math. So at least I can do that while totally and utterly sleep deprived. And then we have 2, which is 0.2 plus 35 times 0.30. So 0.36. Good. And then it comes out to, we don't have to do that with the last one because that's dealt with elsewhere. Now, let's say that, just for the sake of argument, because I haven't done the calculations yet, let's say that there's been an all-in, and the AI now needs to, consider what to do with that information in hand. So the AI is going to treat things differently. if there's been an all-in declared, the AI will be more inclined to fold by 2.5 points, or 200 by 250% more. By 160% more, they will be inclined to call, and by 110% more, they'll be inclined to all-in, and by 50% less, they'll be inclined to raise. This is kind of trying to mimic the behavior of Poker Night 2, which is what I'm trying to base a lot of this off of in terms of what happens. Not the actual values and all that, but just what happens when you play the game, and assuming what's going on in the background. So we want to go ahead and do this calculation. So call was 12. So again, we go 1.2 plus the 3.5, or 0.35, times 2.2 times 0.30. Now we want to go times 1.6. So it's 1.63. Interesting. Enough. So now I want to do the raise, which is 4, so 0.4 plus 35 times 2.2 times 30 times 0.5. So that comes out to 0.24. So, about half less. For fold, which is now going to be should be the largest, although, yeah, well, I don't know, because fold is half of call in this current test line that we're doing here. So it may come up pretty close. 0.6 plus 0.35 times 2.2 times 0.30 times 2.5. So yeah, 1.56. So it's still less than call, but it's pretty close. And then we have all-in, which should be the well, not the lowest, but third lowest. No, second lowest. Third highest. And that was 2, so 2 plus 35 times 2.2 times 0.30 times 1.1. So 0.39. So yeah. Now, after all that's done, we come down here where we actually calculate out what the bet's going to be. Now, this will also be done even if there has been a previous bet. We use that previous bet though as AIB bet, and then we put through this formula here. So the base bet on this first test was 509, and that was within the range of the 385 to 1056. And as you recall, the bet variation was 8. So AIB var is going to be 8 times 12. So 8 times 12. Then that's plus the bet, so 509, divided by 2, plus 509 again, divided times 6, then divided by 4. As you can see, I've done this a lot, so I don't even have to look at to see what it is. So that comes out to 1217, and that's what I got on here. And so that's going to be what the AI is going to bet if it places a bet. Otherwise, if it doesn't have, if there is no bet yet, that will be what it bets on the call, if that's what happens. And if there is a bet, or, well, either way, if it's a raise or a bet with no previous bet, then that's going to get added to the pot and counted as not a raise if it's call, but if it's a raise, it will be a raise. Although technically, no, because if there's nothing in there to raise, if there's no bet to raise, then you can't do a raise. So I think that's essentially what the code says down here. So raise, if less bet was there, if no less bet, then yeah, it's essentially treated as a bet and not a raise. So what this is now is, this was the part that I was agonizing over. I took about maybe 5 hours to try and figure this out. Not the entire 5 hours, but within the span of 5 hours trying to figure it out, and taking breaks, trying to relax my brain from from exploding and catching on fire. Just starting to get a freaking headache from trying to figure this out. So I couldn't figure out how to start it, essentially, and how to interact with these, you know, nifty little values we had cooked up here. And I was, you know, thinking, and I'm thinking, you know what, screw it, let's just use floats and do something with those. So you have the random float, which is what will kind of add more variation to what happens. Because you're not going to just go off of what was the highest action value that you got, because invariably it's going to be call and nothing else, just by the fact that call has a lot of added values to it from the stuff that you got up there. Of course, the formula or math that I'm using here is using, I believe, the adds and subtracts from before I recalibrated it a bit, but so what happens is we do that random here, negative 0.2 to 0.34. Then we do another if or another for loop on I6 this time, and this is going to iterate through the different types of actions that can be done. So that's why it's only to 4. And when you get to 4, if there has been no action chosen done, then and add some breaks. Then you reset the loop and reset the float as well, because that means that nothing has gotten over 0.45. Need to put breaks in here so that we can break out of the for loop if something is done. Otherwise it'll just loop into itself and we'll have all sorts of problems. The good thing about getting this done is that now I can take this and say, you know, just take it and modify it for the other games as needed. Because there are some modifications that will have to be done. Small ones, but still some. So again, we get that random value, and then we go through here, and essentially what happens is we take the float that we get, multiply it by the total, you know, this value that we have calculated, divide it by 0.15, and then if it's greater than 0.45, then we execute that action. Now, the important thing to note here is that whatever action executes, it gets this first, gets executed. Even if, say, call has the higher total, you know, value in the calculated value here, if it doesn't hit 45 because of the, you know, random float, then it's not going to get, you know, done. So that kind of adds a little more variation. It's not going to be the highest every single time. It can also be the, you know, least likely, because there has to be a chance for the least likely to happen, because it's all probability based. So in order for there to be probability, you have to actually add probability. No matter how chintzy or fake it is, you have to have some probability, meaning you have to have the ability to not choose the most likely option and choose another one, even the most least likely option, which is what this does essentially. So let's take our values here, because I haven't put them through this yet to check them. Let's see if they work. So let's say that this float value is 0.10. Now let's go 0.11. That's something quite so clean. Alright, so the first value we're going to put into here is going to be for call. So as they recall, call is 1.02 on the non all-end version, and that gets multiplied by 0.11. Now I would divide that by 0.15, and so we get 7.4. And so in this case, that would be the first one to go, and the AI would do a call. Now let's say just for some reason that wasn't true, and let's do the next one, which is 0.49 for raise. So times 0.11 divided by 0.15. So that wouldn't be enough, so it would continue. And let's try 62, which is the next highest one for fold. 0.62 times 0.11 divided by 0.15. So that would be enough to trigger it. So you would if for some reason the call didn't go, the AI would fold instead. Now let's change that to 0. The float to 0.6. So we go 1.02 times 0.06 and divide that by 15. You get 0.48. So not quite enough. And what would happen now is, since this is the highest number, let's try with 0.6 too. I don't believe that any of these are gonna work now. No. So you would go through it and you would hit the if I6 equals 4, and would redo the thing. And let's say now that we got negative 0. Let's go 0.20. Now this is going to be kind of I think reverse what you might think would happen, but we'll see what happens here. So we got 1.2 times 0.20, throw in the negative, and then divide that by 0.15. So we got 1.6. Now in this case, we would I'll have to go through and add it in. I'll make a to-do for it too. To do if any value calculated value because essentially we'll just calculate it by a negative to make it positive. So that'd be 1.6, and so that's way over. Well, let's do let's do a 0.36. Again, negative, then divided by 15, so 48. Even the lowest option at negative 20 will trigger the thing. So again, it's all a matter of what the values are and what your random values are. And so I think it adds a lot of variability and will probably work pretty well, unless something crazy happens. Which, you know what? I mean, all this code, there's no way there's not going to be huge crash bugs. I mean, it's just, I am physically incapable of creating large code like this that doesn't have game crashing bugs for one reason or another. Either because we have a vector that's not properly initialized, or we're going out of bounds or something. Hopefully, though, I've taken all that into consideration and it doesn't happen this time. But I'm not going to hold my breath because I'm pretty sure it will happen. And that's what I've been doing for the past 8.5 hours, I believe, is just working on all this crap. What we're going to do now is I'm going to do the card exchange thing, card trading I call it, I think. Which is just where you trade in a certain number of cards and get new cards back. So I've calculated this out beforehand, and if you have a maximum of 4 players, which there are including the player, you can do one deck and still be able to do all this stuff, even if you had 5 cards, because each player gets dealt 5 cards, and if they all exchange all 5 cards, that would still just be 40. So what I have is a max of I think is it 3 or 4? I don't know. I think I wrote it down, made a mention of it somewhere. Maybe not though. But it's either going to be 4 or 3 cards that you can get max, trade in max, and that's how that'll work. But you're only going to do that if the betting order is still above 1. Now, if the betting order is equals 1, that means that you're the only that whoever's in there at that time is the only person still left playing, and so they win automatically. Everybody's folded or folded. So everybody else is folded, so they win by default. So card trading, I think I have it named on its own thing here. Yeah, here we go, card trading process. So this is what we essentially want to use. I'll just copy this and we'll paste it over here. Now what we're going to want to do is we're going to want to send a vector through to message processing so that we can have the player choose 3 cards to take out and then send that back to be used for the processing. So, and we can use well, we're already in the betting thing though, but we need to so we're already using I2 and I for the betting and then players, the bet order and the players. So for I3 equals 0, I3 is less than bet order dot size. So if bet order dot at I3 equals mPlayer dot get name. In other words, if the player is the current bettor, else if bet order dot at I3 equals players dot at I2 dot get name. And then if it's an AI player. So, let's go ahead and create the vector. Or maybe we can use one that we already have. Well, why don't we do this? We'll just send through the cards vector. We'll send it through as a reference, and then the player can just, we'll just have the code there over in message processing directly edit the cards vector. So we'll need to add the thing here, void, so we're not sending anything back. SCP-5 Poker 5 CT menu. So we want to send through vector string and cards, and then we want to send through do we need to send anything else? No, because that's all. Well, we'll find out. I guess we'll figure it out as we go. Casino, 5 card. Card trading menu. Oops, accidentally deleted the semicolon there. Alright, so we want to take the So I'm going to grab this. And let's see. We'll use, because this is going to have to be a while loop situation. Equals false. While be valid is false. Do whatever's in here. So we'll have that. Count. And we'll say, you know, use 0 if you don't want to. If you want to either stop trading cards or taking cards out, or if you don't want to trade any cards at all. So count. Let's do another for loop. So count I2. And the only reason we're using 0 is, or I is for the conditional statement there in the middle. We have to do a size -1 or something for the I2 if we're going to do it that way, and it would just be totally messed up. So we're just going to kind of skip over having to do all that craziness. So essentially we just do that, and then when we get to the after it ends the loop there, we'll say count, do our thing here, then send p choice, and do the double line del again. So if choice is less than 0, or p choice is greater than cards.size count. Now I believe this will be a kind of an end-all kind of thing, because if the size of cards is 2 and you select 3, it'll do this. If it's 1 and you say 0, well, that's fine. If it's 1 and you say 2, it'll hit this. If you say 5 and it's 4, it'll hit this. So I think that this will be fine for now. So be valid equals true. In other words, there will be no cards taken out. But else, if p choice b valid equals true, and then else if p choice is not 0 and is within the range of cards, we say we want to essentially take that card out of your hand, and then we go back there and redo the hand. So cards dot at I2 minus 1 dot erase cards dot begin plus I2 minus 1. Card size is greater than 2. Because if it's less than or if it's, that means that we would have taken more than 3 cards. Since there's only 3 cards available for you to remove, that means that the minimum amount of cards. So essentially this is how to go. So if p choice is less than 0, then we escape out. If p choice is greater than what the size of cards is, we also escape out. If p choice equals 0 and is within the range of cards, then we leave, because at that point the player's saying, I don't want to any more cards or remove any cards at all. But if that's still not true, then we hit this, and if cards is greater than 2, then we erase the element that the not I2. But yeah, if cards dot size is greater than 2, which, with it we still go back to once it's a thing, and then we're going to give those cards back. So mp underscore sc5c menu and scph or scp hands dot at 0 dot cards for I4 equals scp hand dot at 0 dot cards dot size as long as I4 plus plus. And we essentially want to do the same thing we did up here with adding the cards. Let's go up here and grab the code for that. Let's bring it back. Card. Where the hell is that at? So let's copy that down to here. And there you have it. Pretty simple though. So we'll go with rint3 equals random 1 to 30. R well, not pretty simple, because now we have to go through and check to see, what kind of outliers and stuff there are for this guy. Something off of that. So let's not go later. This section, or at least I will, because I'm just too totally smashed to try and figure that out now. As far as being sleep deprived rather. Well, depraved too. Whatever that is, onto this, or at least as near to it as possible. So until then. This is Geo, and I will see you later.